Hello, we're here to talk to you about an ecosystem. An ecosystem is a place where plants and animals, which are living things, live along with non-living things, such as air, water, and soil. Our ecosystem, or biome, is an ocean. A biome is just a larger version of an ecosystem. Far, far away, over 7,000 miles, is an ocean located at 18 degrees south and 147 degrees east. There is a group of friendly, fishy friends there. In this group of friends, there is a leatherback sea turtle, a clownfish, and a blue tangfish. This group always goes everywhere together, and they don't allow any other living things, or biotic factors, into their group. One day, a lonely organism tried to join their group of consumers. He was a Christmas tree worm, but they didn't like him because he was a living thing that only consumed plants, or a herbivore. This particular herbivore was strictly limited to the producer phytoplankton. The fishy friends were carnivores, which ate only meat, and omnivores, which ate meat and plants. They especially enjoyed other fish, jellyfish, and mollusks. They wouldn't let him join their group, and this made the Christmas tree worm very sad, so he stayed where he was while all the other consumers swam away. Then, next to him, he heard a small group of producers, or autotrophic organisms who undergo photosynthesis, consisting of calcareous, seagrass, mangroves, and caulopa. "You can be our friend," they said. This made the Christmas tree worm very happy. While the new group of friends were hanging out, they noticed some lonely decomposers and detrivores. There was a sea cucumber, red algae, and bacteria. "Do you want to be our friend?" the Christmas tree worm asked. "Sure," said the sea cucumber. "I hope you don't mind if we eat you when you die." Sure," said the Christmas tree worm. And they were all very happy. Little did they know, when they were adding the sea cucumber to their group, they were also inviting the pearlfish along, who partook in a commensalism symbiotic relationship with the sea cucumber. This means that one of the organisms benefited from the situation, and the other went along unharmed. The pearlfish resides near the rear of the sea cucumber for protection, and the sea cucumber goes unaffected. Until several abiotic factors came through. Abiotic factors are physical factors that affect the environment. The first factor was wind. The wind caused such a strong current that lots of coral and a baby dugong blew away very quickly. Next, a tropical cyclone, which is a low-pressure system, came through and destroyed even more coral. Lastly, the chemical composition of the water rose, which was caused by the pesticide runoff into the water, and killed the sea anemone. This is an indirect human impact caused by negligence and carelessness. Because of the pesticides being produced by humans, not only are the sea anemone in danger, but also the coral that so much of the ecosystem relies on. If the coral dies, then the plants cannot sustain food, and then the fish that rely on the plants will also die. For example, the red algae in our decomposer group relies on the nutrients in the water. If the ocean is polluted, the red algae will die off. The blue tang in our fishy friends group relies heavily on the red algae as a food source. As the amount of red algae decreases, there would be a greater competition amongst the blue tang population, as well as with other fish. This would be extremely detrimental to the ecosystem as a whole. This is a major density-independent limiting factor on this ecosystem. It is a density-independent limiting factor because it does not matter the size of the population. This human impact is going to affect the population regardless. Another example of a density-independent limiting factor is a natural disaster. In the case of a natural disaster, there will be many steps towards secondary succession. First, in order for the ecosystem to return, all of the organisms would have to come back. The calcareous, the seagrass, and the hard coral would be the first to show up. This would happen because all they need are water, nutrients in the soil, and the sun to survive. They also make their own food. Next to show up would be the green leatherback turtle, the clownfish, other small fish, and dugongs. These come next because they can survive off of corals, seagrass, and water that is already there. They will then create food for bigger animals, such as the dwarf minke whales and sharks. The sea cucumbers and the decomposers would be last to show up because they would eat off of the medium-sized animals. These are the final parts of the food chain. Since we have discussed the effects of a density-independent factor, we should also discuss density-dependent limiting factors in this ecosystem. An example of one of these, which is very common, is predation. Checking back in on our fishy friends, we can see the effects of predation between the blue tangfish and the Christmas tree worm. While we already knew that they did not get along very well, the blue tangfish can also be a predator of the Christmas tree worm, which means that they consume the Christmas tree worm. That would make the Christmas tree worm prey in this case. On the same day that the Christmas tree worm was making friends with the producers, the detrivores, and the decomposers, the friendly fishy group was hanging out. A mutual acquaintance of theirs, the dwarf minke whale, happened to swim by and say hello. The always intuitive leatherback sea turtle turned to his comrades and said, "Look at the dwarf minke whale. He's a tertiary consumer, which means that he is at the top of the energy pyramid, which shows how much energy that each of the organisms in our ecosystem has. Since he's at the top, he has the least amount of energy. We are the primary consumers, which means we have the second greatest amount of energy because we eat the primary producers, who have the most amount of energy." The clownfish, in turn, wanted to know more about the ocean surrounding him, so he turned to the leatherback sea turtle and asked him more about the cycles that go on in the ocean. The leatherback sea turtle then turned to his friend and told him about the nitrogen cycle, which has 4 main steps. The turtle explained that nitrogen is an element that exists in many forms, and that dinitrogen, which is inexhaustible, is a source that is the dominant component of the air that they breathe. But it is inaccessible to most living organisms because the nitrogen molecules are bound tightly together. Living organisms require fixed nitrogen to biosynthesize their nucleotides and amino acids, hence fixed nitrogen. The nitrogen cycle involves nitrogen fixation, denitrification, consumption of the nitrogen, and decomposition. After a long day of fun and learning, the clownfish decided to go back to its home, the sea anemone. The sea anemone provided protection for the clownfish, and in return, the clownfish lured prey into the sea anemone to help it catch food. This is an example of a mutualism symbiotic relationship, where both of the organisms benefit through the relationship. Thank you for visiting all of our friends in the Great Barrier Reef today. We hope you'll come back soon and learn more about our amazing ecosystem in the ocean.